Hey there everyone, this is Zare, back with some more Advent of Code. Let's solve Tron. Okay, so this looks like a fairly short problem. A new system policy has been put in place that requires all accounts to use a passphrase instead of simply a password. Passphrase consists of a series of words, separated by spaces. To ensure security, a valid passphrase must contain no duplicate words. So that's valid. That's not valid because we've got two A's. And those are different words. System's full passphrase list is available as your puzzle input. Let's take a look at that. How many passphrases are valid? No, I don't need that translated. That's a lot. So put that into our input. Okay, so how are we going to address this? Well, we can very easily just search each row for any duplicate words. Might want to double check how C# handles string equality. It seems fairly straightforward, not particularly efficient, but it's workable. Alright, so first our test cases. That's going to return us 1. Double A, so we'll return us 0. Triple A is going to return us 1. Okay, so we are going to need parse input. It's just going to return. What do we need here? I suppose a list of strings is appropriate. Alright, so we need to split that input. Alright, this gives us an array. Dot split. And we need to make that a character. And then list. Okay, and then for each entry in the input array, first of all, we're going to need a new list. You do not need that. And then we need to break this down into individual ones. Hello, Fida. Welcome to the stream. Watching from TV, and I'm watching from my new monitor. Exciting times. Alright, so next up, just split this based on spaces. Let's just double check our input. Yeah, it looks like they're all based on spaces, so we can just use a split here. So it's going to be array of string. Entry.split character. Oops. Biggest of screens. My new monitor can actually rotate, so I'm going to be very interested in trying this out vertical style, but I don't think the stream's the best place to start that off. Also, this monitor is huge, way bigger than I expected it to be. It's somewhere between 24 and 26 inches. So where's I? String, word, and words. Nope. Pass, phrase, add, word. And once you're done there, pass phrases, add, pass phrase. So that should get us our input, and then finally return pass phrases. So let's first just take a look at what our input looks like. Hey, welcome to the stream. Oh, the kids were starting to try the problems. How'd they do? Input. Where's I? So first of all, we need to get the list of strings. So, parse. Oops. For each access violation. Perfect. The guy had deemed the smart one couldn't. And the lazier one solved it in half an hour. Ah, that's quite the reversal. So we'll write B plus underscore, just so that we know that we've mutated it a bit. So that should take the debug, parse it. For each one, we're going to print it out with underscores instead of spaces. New lines each time. Let's give it a spin. Oh wait, the test cases are probably going to fail, aren't they? Oh, but it did get the input correct. So that's good. All right, so let's switch back to the problem. So how many passphrases are valid? We got our word there. So we're going to first need a function to check if it is valid. This is going to return a Boolean. So what are our rules? So the only thing we need to worry about here is that we don't have any duplicate words. So we're going to have a return true. And then what's the best way to handle this? So for each passphrase, we're going to have to take the first word. We're going to have to search it across all the other words in that passphrase, and we're going to have to check if there's a duplicate. If there is a duplicate, then we need to return false. Now, we can definitely skip the final word, because if we don't find any matches in all the n-1 words, then the last word is not going to match any of the previous ones we checked. Is there a better way? Oh, you could sort them. Can we sort lists? Oh, list t.sort. It's promising. Sort. Pay method implemented on part. Okay, well, let's just try sort first. So, just be a little consistent there. For each word in the passphrase. Oh, is there a list.next? Because the for each here, we're not going to have an index. Oh, index of, perfect. So instead of that, all right, thanks for dropping by, Sfida. Have a good night. And that's less than passphrase dot count plus passphrase dot index. Oh, what am I thinking? Index of. That's not what I want. Because that's going to search for an item that I pull out. It's not going to get me an index. Anything here? It's to array. Yeah, let's just do that. So array of strings. Passphrase dot sort dot to array. Oh, so that doesn't return, it sorts in place. Can we copy a list? Copies the entire to a compatible one-dimensional array. So the beginning of the target array. No, that's not what I need. Okay, well, let's just do this. If we need to preserve it for the second part, then we'll deal with it then. This is going to mutate it in place. And as we mentioned, we don't need to check the last one, so -1 there. So equals parse input put each we're going to test that method. Let's try it. True, false, true. It's not how I was expecting it to come out, but that's exactly what I was looking for. Alright, so for each passphrase in our list of passphrases, if is passphrase valid, valid passphrases plus plus. Return a stringified version of that. That's passed 468. It's not the right answer. Answer is too high. So we're getting a valid passphrase that shouldn't be valid. Is it not sorting properly? Let's take a look here. C# sort list string. Sort of list alphabetically. Yeah. The bug in that example. Okay, well, let's do this then. Turn false. Console.write line. Passphrase. We gotta format that because it's just gonna. Oh, we can do string. Make sure we remember this is debug. Did not help. Okay. Do we need to put each string word in passphrase? Dot. And then write new line. Okay, so I'm not immediately seeing anything with duplicates, but this is going to take a while. There's an alternate way to do this, actually. Because I think you can do this with regexes. So maybe that's the way. That is... Oh, you're running, that's fine. Of our string. Each word in passphrase. We need to check that regex. So regex duplicate word. Okay, so where did we use the regex before? Because I just want to copy and paste that. Yes. So instead of this, what we want is so this phrase right here is going to look for the boundary of a word followed by a series of non-white space followed by another boundary of the word. And then so one or more combination of was words. Regex, escape characters. Actually, let's make this simple. Just anything followed by 1. So this will match a word, and this refers to that first word. So if we get a match where there is some word followed by any amount of anything followed by that same word, then we know we've got a duplicate. And you needed that. And then, so we need to look for a single match. We don't need to store which matches there are. Regular expression specified in the finds a match in the specified. Okay. Regex dot is match pass string. Okay, that didn't work. Ew. Really? So we're just getting that. Because I'm not adding. That's why. So we are getting the full words. The second one passed. Wait, no, the second one did not pass. This one passed. And the third one passed. That doesn't make sense. Well, first thing, we should be returning the opposite. this should be catching that we need a boundary, so AA and AAA should not be matching. Yeah, those are boundaries. So I think it's got to be matching on the A's. Why is it not respecting that I want a boundary? Let's try this then. There we go. Okay, so there were two passphrases where the first method was failing. Alright, moving on. For added security, yet another system policy has been put in place. Now, a valid passphrase must contain no two words that are anagrams of each other. A passphrase is invalid if any word's letters can be rearranged to form any other word in the passphrase. Okay, got it. So we can do something similar here, or similar to the first solution that we had, but we need to make sure that that first solution is working first. Because the plan would be here that, hold on, you know, the system policy, now a valid passphrase must. So does this mean that we still need the original validation? So we can't have any clones and we can't have any anagrams? Not that it really matters, because if you've got an anagram, a clone would be an anagram of itself. So the plan would be to, first of all, get the list of words in the password. And for each word, sort the characters in that so that they're alphabetized. And then from there, match each word in the passphrase. Okay, so first of all, we're going to need to change this function. So we want So let's just double check our string equality. ignore casing. I don't need that. Okay, actually, let's do this first. Let's figure out where we're tripping up. All right, so this is our solution in the last one using the regex. And this is going to be our original solution not using the regex. And so we want to check for each string, if it's one of these but not the other, we are going to print it out. And we're going to see what could possibly be happening. If not has duplicate. Do I want foo or not foo? Okay, so this is going to check not has duplicate. So yeah, I think it's that. Console.write line. That's a list that's not printable. Build errors. We are expecting a close brace somewhere. Down here. Okay, so we're writing AA, BB, CC, DD. We're failing all of our tests because we're getting the exact opposite of what we want. Because these should be reversed. They are sorting these, that's good. And these are each coming up different, which is not as good. It was worth a shot. Hold on. We're getting 468, so there's still those two that are matching that shouldn't be. We sort the passphrase, that's correct. String passphrase array. Okay, well, let's stop worrying too much about this. Passphrase. Goes for 1. With the solution we had planned, it's not going to matter which of these we use. They're both going to, well, no, the other one is going to provide a different answer. But we can mostly follow it. So first of all, we want an array of characters. We need something different for our character array. Quick cheaty solution. Oops. C to C. Oh, array to sort. Okay. That's even better. We don't need the right lines. Those are debugs. Don't need you. Duplicate count. Oops, I wanted to keep some of that code still. Private. What are you complaining about? Cannot convert type string to string. Oh. Wait, what is going on here? That's what's going on. Okay, let's confirm 1 still works. Yep. And part 2 says 0. That seems suspect. And I also haven't added my tests yet, so let's do that. Get all of these. valid, is valid, is valid, is not valid. Okay, so those three failed. So this first one failed here. Why did that fail? Ah, that'd do it. Now, all those words are looking pretty identical there. For each letter in array, pass string equals letter. $251. That took way longer than it should have. Alright, before we get to the next problem, let's just clean up here a little bit. Yeah, okay. This still doesn't make any sense, but... Part 5. Urgent interrupt arrives from the CPU. It's trapped in a maze of jump instructions and would like assistance from any programs with spare cycles to help find the exit. Message includes a list of the offsets for each jump. Jumps are relative. -1 moves to the previous instruction, and 2 skips to the next one. Skips the next one, okay. So the first instruction on the list, the goal is to follow the jumps until one leads outside the list. In addition, these instructions are a little strange. After each jump, the offset of that instruction increases by 1. So if you come across an offset of 3, you would move 3 instructions forward, but change it to a 4 the next time is... What? For each jump, the offset of that instruction increases by 1. So if you come across an offset of 3... you would move 3 instructions forward, but change it to a 4 for the next time it's encountered. Okay, these examples are going to help. Positive jumps forward, move downward. Negative jumps move upward. For legibility in this example, these offsets will be written all in one line with the current instruction marked in parentheses. Following steps would be taken before an exit. Right, so before we have taken any sense, with offset 0, don't jump at all. Then becomes a 1. And then you increment it again and head to the next one. And then you increment that one and head to the next one. And then you increment that one and head to that one. And then jump 4 steps forward and we're out of the maze. How many steps does it take to reach the exit? Well, let's grab our input. That's a long list. So do we have any indication how big this list is? Oh, yeah, the size of the list itself. Makes sense. Okay, so our first test case, and our only test case at this point, why do you keep doing that? So we've got 0, 3, 0, 1, -3. And this is going to come back with 5 steps. And we're doing it for part 1. So we want an array of integers. So first we're going to get an array of strings by splitting the input on the new lines. We can't do that. Because we don't know how big this input is going to be. I suppose we could find that out, actually. Going to be the size of the input array. No. For int I equals 0, so less than or equal to input array dot length. Not even equals to. Equals input array I. We need to convert that into an int. And hopefully this is smart enough to handle negatives. Check our input. Need to switch parts. Okay, yep, that looks good. Am I getting another output though? Why do I have the array? Oh, right, because that's a test fail message. Got it. input is good. Alright, so we need to keep track of how many steps we've got. So int steps taken. Int current index. And we are going to need to change this in place. So, is there an easy way, or do we just have to iterate over and... Oh, we have an array copy. Array.copy instructions into mutated instructions. And we'll do that for the instructions.length. Are you not happy? All right. So while our current index is greater than 0, equal to 0, and current index is less than instructions.length, steps taken, going to need to increment. And mutated instructions at the current index. It's going to go up 1. And current index plus equals mutated instructions current index minus 1. Straightforward enough. That's a lot of steps. Somehow I'm suspicious of this. We'll try it out. Gold star. Now the jumps are even stranger. After each jump, if the offset was 3 or more, instead decrease it by 1. Otherwise, increase it by 1 as before. In this rule, the above example, the process now takes 10 steps. The offset values after finding the exit are left as 2, 3, 2, 3, negative 1. How many steps does it take to reach the new exit? All right. So it's more or less going to be what this was. I do want to clean this up a bit. Instruction. Oh, I've got caps lock on. Just so that there's no real confusion. It just doesn't look nice to have us incrementing one and then decrementing that one after. The hardest part of this is figuring out how to name these different parts. Instruction is 3 or more, so greater than or equal to 3. Instructions, current index, minus, else. Switch part. Alright, that looks about right. Try it out. Failed. I didn't change the part. And speaking of changing the parts, just gonna copy that. Gold star. This continues to not make any sense yet. But last puzzle for the day. Memory reallocation. That sounds like it's going to be a blast. Debugger program here is having an issue. It is trying to repair a memory reallocation routine, but it keeps getting stuck in an infinite loop. I know, after that first one and the disaster that I was going through, that one was just absolutely destroyed. It's nice to have an easy one now and then. In this area there's 16 memory banks. Each memory bank can hold any number of blocks. The goal of the reallocation routine is to balance the blocks between the memory banks. The reallocation routine operates in cycles. Before I forget, commit my code. Solve 2017, day 5. Operates in cycles. In each cycle, it finds the memory bank with the most blocks, ties one by the lowest numbered memory bank, and redistributes those blocks among the banks. To do this, it removes all the blocks from the selected bank, then moves to the next by index memory bank and inserts one of the blocks. It continues doing this until it runs out of blocks. If it reaches the last memory bank, it wraps around to the first one. The debugger would like to know how many redistributions can be done before blocks and banks configuration is produced that has been seen before. Alright, let's walk through the example. Scenario with only 4 memory banks. Banks start with 0, 2, 7, and 0 blocks. Third bank has the most blocks, so it's chosen for redistribution. Start with the next bank, then continuing to the first bank, the second bank, and so on. The 7 blocks are spread out over the memory bank. So without looking at this, we should go 1, 1, 3, 1, 2, 2, 4, 2. 1, but just going to distribute to all of them. Oh, right, and all the others are 1, 3, and this one would be the last one, but since there isn't an 8th one, this doesn't get updated. So 2, 4, 1, 2. I see. So because it contains the most blocks, because there are 4 memory banks, each one gets 1 block. 1, 2, 3. Now there's a tie between the first and fourth memory banks, both of which have 3 blocks. The first bank wins the tie, and its 3 blocks are distributed evenly over the other 3 banks. With 0, 2, 3, 4. The fourth bank is chosen, and its 4 blocks are distributed such that each of the 4 banks receives 1, 1, 3, 4, 1. Third bank, the same thing happens, 2, 4, 1, 2, and that's a loop. The initial block counts in your puzzle input. How many redistribution cycles must be completed before configuration is produced that has been seen before? Oh boy, this is going to be a mess. How big's our input? That's not so bad. Is that right? Starts with 4. Okay, yeah. So the reason this is going to get ugly is because we're starting to get into an n-square routine. Because every time we get a configuration, we need to add it to the list, and we need to check the entire list if that configuration existed before. And so every iteration we go through is going to make the process take longer and longer and longer. But thankfully, we only have to deal with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 banks. So while we're probably going to breach 100 milliseconds here, it could be a lot worse. Okay, so our input, these are tabs. So we need 0, \t, not \2, \t7, \t0. And this is going to give us an answer of 5. This is for part 1. So we can use an array here. We don't need a list. Yeah, an array is fine. Parse input. Okay. So it's going to return int get steps loop. Alright, so we're going to need an int and pass count. And we're going to need a list, int arrays. All right, so we'll write that function after. Previous configs add let's just do open day 5 to copy from there. This is sounding very similar at this point. Okay, so we're going to add that. Not previous configs dot contains current memory config. Method name expected. Yeah, you don't need that. All right, so we're going to add our current memory configuration to our memory, and then we're going to try to step through it again. Alright, so we need to be able to find the maximum value in the memory configuration, or rather the index of it. And then once we've got the index, we need to iterate over the array multiple times until we get that done. distributor bank index. Let's get index. We'll just assume that exists for now. Int. What are these called? Blocks to distribute. Those memory config dot no. And we're going to need to mutate it. I imagine we could use pointers here. I'm not that up on pointers, so I should probably study those between now and Sunday. So I'm just going to do it this way for now. Because this one, we already cloned it, so we don't care if this perseveres between iterations of this. Memory config distributor index now equals 0. And we need a next bank index. So if we're already past the end, that's going to wrap us around. And so next we do allocated config next bank index plus and blocks to distribute minus. Alright, so that's going to reallocate memory. We're going to see if that already exists. The only thing left is to get the max index. So first of all, we need to get the maximum. Oops, not max array size. Find the highest array value and index. Okay, perfect. So all we have to do is can't do that. Is that for C#? Why is it not like that? Does not contain a definition for max, and no extension method max accepting first argument of type int could be found. All right, let's do it manually. Array 0. I equals 0, 1, because we already got the first one. Then if array I is greater than max value, and we can do this in parallel. In fact, we don't even need to be saving the value here. No, we do for comparison's sake. Equals 0. Let's go. Oh, it's working. I'm thinking I've reached an infinite loop here. I didn't even finish the tests. Okay, where can I do? Current memory config 0123 0270. Yep. Previous configs. Okay, so next we're at 2482. That's not right. This should have been set to 0. So where is it not getting set to 0? This should have set it to 0. Why did it not? Because I am not doing the reallocated config. Okay, that's still not doing it. Okay. We're still at 0270. Continue. So now we're at 2412. That is correct. 3123, 0234, 1341, 2412. So now it should be checking if we have that. which there 2412 2412. So we should have that. But when we continue, we're back here. We did 3123 again, and it keeps going. So this is not working. True if item is found in the list T, otherwise false. Oh, hold on. Maybe it doesn't know how to compare arrays. Okay. So let's just customize that then. Int item list. These should be int arrays. All right. So first of all, if item.length not equal array.length, then we are done here. Each, no, not just before, index then item.length. Oh, this should never happen, but whatever. Doesn't particularly hurt to have it. If going through the list, so we're going to get one array if item I equals array I, and actually we want the opposite. No, not return false. Continue. Wait, break. Okay, so this block, we're going to check each array in the list. Then here we're going to check each element of the array against the target array. If we find a mismatch, then we break out of this and go for the next item. No, this is only going to break out the for loop, so I need something else here. I could just keep a Boolean to track. I feel like there's a better way. I can just turn this into a function. Build errors. All right, got it. Expected 5, got 0. List contains array. Am I not incrementing pass count? I am not. Pistol passed. 2.51 seconds. And that just closed my window, so let me open that again. 12841. Correct answer. Next problem. Out of curiosity, the debugger would also like to know the size of the loop. Starting from a state that has already been seen, how many block redistribution cycles must be performed before that same state is seen again? An example 2412 is seen again after 4 cycles, so the answer in that example would be 4. How many cycles are in the infinite loop that arises from the configuration in your puzzle input? Part 2, and you are going to get us 4. Right, so once we've found the loop, some of the initial steps won't be included in that loop. All right, what's the best way to do this? So we already know how many times we have to go through to get that loop. So we could... No, we can't do that. I was thinking that we could go through the loop, find the point where we get a duplicate, get the next... No, wait. Okay, so we go through all that. We find out what the duplicate is, And then we can go back and find that. Yeah, this works. Okay, sorry, I am getting very confused here. So initially I was getting stuck on thinking that the index of the array was shifting normally, but it's always looking for the maximum value. So given any array, it doesn't matter how many configurations we've had before it, it will always start with the same one. So that's not a problem. So from there, we just need to find the first instance of the duplicate. Okay. Private int get index of list should have something like this, but we've already established that it can't smartly go through arrays. If we don't find anything, we'll return -1, so that's a good error state. All right, so get the size of the loop. So we are going to copy this over. It's no problem. But we're not going to return the pass count. Instead, this is going to finish when we found the duplicate. So vs configs dot get index of array and list. So that's going to look through that. It's going to find the last one. Let's just make it more explicit. Do we accept -1 here? We're going to find out. So pass count is how many steps we took to get to that loop detection. And the index of the first instance of that array that we detected the loop on. That should get us our start point. We may have an off by 1 error in here, but we'll just sort of feel that out. Expected 4 got 5. That needs to be out of here. This is a cheeky way to pass the... I don't even pass the test. Right, because I have not set up my solve to switch on the part. And we broke. The argument, find string or find exact string. Argument out of range exception. Okay, so -1 does not work. Previous configs dot count -1. Expected 4 got 1. We got 5 and we came out with 4. Okay, so this is clearly getting us the wrong number. Get index of array of lists. Arrays match, list I, array, return I. Okay, so here we've got array 1341. What stage are we at here? The 4th bank. What? We're checking. Hold on. This seems like a very weird thing to have be the problem, but range exception. Yeah, that's what I thought. Oh, okay. So actually, I don't need to do this. Oh, test all passed. It says 808. 8038, rather. There we go. Still very pretty. Alright, so that is going to wrap it up for tonight. I don't want to cheat because the 7th is tomorrow. And besides, leave 4 for the Sunday. So thank you everyone for coming on out. I'm going to clean this up a little bit, update my GitHub. And until next time, take care.